Thank you very much, the chair, for the nice introduction, brief but very informative. And also thank you very much to the audience for coming, and to the conference organizer for letting me this opportunity to present you this very briefly, the overview of the topic, which you have on this first slide. Also, thank you very much for the local organizing committee and all the technical support to actually make this technically happen also. So I will start just saying that the topic is, I was working on that topic in parallel to some other things for a long time, so it's very difficult for me to suppress the whole material in 50 minutes. So I try to give you the overview. Sometimes I'll skip some mathematical, of course, details, but I try to actually tell you the most important issue, the difficulties, the implications, the generalizations, and some application. That is what the idea is, and I'm trying to present you this topic from few points of view. From the point of view of the modeling, okay, simulation, from the point of view of a good approximation, and from the point of view of sparse versus dense data. You will see that approach has to be different, at least for sparse data. So we start, and briefly the overview. So we will actually, I'll show you the difference between classical and non-classical approach, which means reduced versus non-reduced data, some numerical issues and numerical tests. Then we switch to sparse data, when the approach has to be different, has to be actually an optimization, not actually the question of convergence is not irrelevant here, of course. And some algorithm, you will see some technical difficulties which are occurring if you want to apply a feasible algorithm. So I will present you a few algorithms, including leapfrog algorithm, which is a feasible alternative. And the good thing about that is that this algorithm can be applied to an optimization problem, which has a lot of variables, and it is a sum of some sub-functions, and each of them only depends on smaller collections of variables, okay? So not only in that context, and as a matter of fact, we apply this algorithm in other contexts. Some experiments, and if I have a time, I will say more or less about some geometrical also enforcement, which means partial interpolation. At the cost of missing some interpolation points, I would like to enforce actually some geometrical extra properties on the interpolant. So we go to the